Okay, let's look at an example for quiz 7, number 1. All right, so we want to evaluate this limit using L'Hopital's rule. All right, so let's do that. Before we apply L'Hopital's rule, I'm going to have to review some derivatives, right? For example, e to the some power. So you have e to the, say, g of x. Then we want to take the derivative of this, right? Then all you have to do is, right, copy exactly the same thing. So e to the g of x. Then you have to multiply by derivative of g, so g prime of x, right? So this is by chain rule, right? And also, when you have a natural log of, say, g of x, right? So some expression is plugged into log function. Then let's say we want to take the derivative, right? So this derivative is going to be anything that's inside the natural log. So you just copy that down here, right? Take the derivative of that, put it on top. So that's the chain rule part, right? Right, so this is a derivative of natural log of g of x, right? All right, first thing we should do is we just kind of plug in. So let x go to positive infinity, right? You have e to the negative infinity. Remember that the exponential function with the negative power, right? E to the negative x looks like this, right? It's a decreasing exponential function, like this. All right, so go through 1. This is y equals e to the negative x, right? So as x value gets larger and larger, and the y value gets closer to 0, right? So you can see that as x approaches positive infinity, right, this guy, e to the negative x, goes to 0, which means that the whole top is going to approach 0, right? And on the bottom, you can see that you have this guy approaches 0, so this part goes to 0, right? But you have a natural log of 1. So this is going to approach natural log of 1, which is actually 0. So the whole thing, whole bottom approaches 0. Right? So since you have 0 over 0, we can apply L'Hopital's rule. Right? So let's apply L'Hopital's rule. Right? So I'll put LR to indicate that I'm applying L'Hopital's rule. Right? So we still have the limit as x approaches infinity. Right? Then you take the derivative of the top, right? So 4 is there, it's just a constant multiple, right? Derivative of e to the x is, e to the negative x would be e to the negative x, right? Multiplied by derivative of negative x, which is negative 1, right? That's the derivative, right? Bottom one is natural log of quantity 1 plus 3 e to the negative x, right? So we have to use this rule. So whatever inside the natural log, we put it as a denominator. So it's going to be 1 plus 3 times e to the negative x, right? Then we take the derivative of this and put it on top. Derivative of 1 is 0, so I'm not going to write anything there. And the 3 is there, right? Then derivative of e to the x is, e to the negative x is e to the negative x multiplied by negative 1, right? So we can cancel a bunch of things. Here you have a negative 1 on top, negative 1 on the bottom, all right? E to the negative x on top e to the negative x on the bottom, right? You can cancel that. All right, so since you have, I don't like to have a fraction inside the fraction, so I'm going to go ahead and multiply top and bottom by this denominator so that I can get rid of the denominator. So I'm going to multiply this by quantity 1 plus 3 e to the negative x, right? Then I have to multiply the numerator by the same thing so that I don't change anything. So you have a 3 e to the negative x, right? So on the bottom you have exactly the same thing. This guy and 1 plus 3 e to the negative x cancel out. So what's left is this, right? So 4 over 3. So 4 over 3, it's just a constant, so we can put it outside the limit. So 4/3 is outside. Then you have a limit as x approaches infinity, right? And what's left is just this guy, right? So you have a quantity 1 plus 3 e to the negative x, right? Then as the x approaches 0, we know that this guy right here, as we said, goes to 0. So this guy approaches 0, right? So what's left is 4/3 times 1 plus 0, which is just 4/3. So this is going to be equal to 4/3. Right? This is it. Right, that's it. I hope that this was clear.